We're going to find a greatest common factor here. I have my calculator out, and there's a reason for that. There's some little techniques that come into play that the calculator can be really helpful with. And so, it's probably something that you're going to want to take into account. Also, some strategies for verifying whether or not your expression, your final answer, is equivalent to what you started with. Now, we've talked about this, a while ago, but it's very rare that I see people doing it, and that is using the test function in your calculator to see if an expression is or an equation is true or false. There is a benefit to doing that, and the reason is that sometimes, if you're tackling a multiple choice question that you don't know the answer to, the calculator can figure it out for you, whereas you might otherwise have to take just a shot in the dark, just a complete guess. All right, and so moving forward, it's going to be even more important because factoring it typically is kind of the line of demarcation in this course between middle school math and high school math. All right, so because in the first quarter, early parts of the second quarter, you may have even already hit that mark, because some people hit it in the functions unit, because that's when things start looking different, but it isn't really different. You're still plugging values in and getting numbers. When you plug in a number for X, you get a number for Y, and so on. But it's really in this unit that things start moving in a different direction. And so you're going to want to rely a little bit more on technology than you have in the past, right? So if you've been relying on it heavily, you're going to rely on it more heavily. If you haven't been relying on it at all, you'll rely on it a little bit. So it'll be a little bit of an uptick from where you were, all right? So you can look at number one and say, okay, greatest common factor, I could easily figure that out. You're just looking for the largest number that could be divided evenly into the two given numbers. All right, so I'll just make a note of that. So largest number that could be divided evenly into the two given numbers. And I'll even expand it. Instead of saying the two given numbers, I'll say the given numbers. Because it is possible you might have to find the greatest common factor between 10 numbers. Not in this class, but down the line. So largest number that could be divided evenly into the given numbers. All right. So it's going to come down, if you're not using a calculator, it's going to come down to number sense. Do you know your multiples of 6 and 12 and things like that, right? Or not. All right, so what do you say for number one? 8, 12. Anything better than 12? 24. Oh, that's not a 24. All right, so these are our candidates. Let's see what the calculator says. All right, so you're going to hit math. You're going to go to the NUM option. All right, the calculator, it's kind of weird. Sometimes they do things exactly the way we want it to do those things, and sometimes it does it slightly differently, enough to be annoying. So GCD is the one that we want. All right, so the D stands for divisor, greatest common divisor. All right, so you select GCD and type in your two numbers, 72, 96. So 24 is our winner. Oh, that's not a highlighter. That's not a good highlighter. All right. So, if you have 6 and 12, you don't need a calculator for that. 2 and 4, 1 and 5, those are things you don't need a calculator for. but 17 and 59? Yeah. I'll just do the process again. Math, go to the NUM menu.
Thank you, sir.
You're welcome. It's one of those things where after you see it in action, it's like, maybe I want to get in on that. All right. So math, go to the NUM column, type in, or select GCD, then type in the 17 and the 59. All right. You get a value of 1, which is telling us that there aren't any non-trivial values. This is called the trivial value. Or the trivial case. You don't have any non-trivial values that divide into 17 and 59. All right. So if I were to say something like, basically the trivial case is really what it sort of sounds like. It's the eye roll. You know, it's like if I say, give me a number that divides into 120 and you say 1, I'm like, give me a number besides 1. 0. Okay. Give me something more meaningful than that. All right. This is an eye roll number. All right. 0 and 1. Those are eye roll numbers. Actually, 0, it doesn't even divide evenly into anything because it would be undefined. But 1 is the value that wouldn't really add anything to the situation. All right. Number 3. Now, you look at this and say, okay, well, it was good while it lasted. Calculator's not going to help us because we have variables. Calculator's not going to understand the variables, at least not in the way that we want it to. All right, so what we want to do is, at least this one time, is rewrite our expressions. X, 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 Y, 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 Y. So that's the first one. And X, X, Y. All right, so the term itself can be confusing. Greatest common. The greatest part can be confusing because you look at it and say, well, x to the third, x to the second. 3 is greater than 2. But then it's greatest common. All right, so what we were looking for is the most values of x and y that are in common between the two expressions. Bless you. All right, so what is the most number of common x's between the two expressions? 2 of them. All right. Yeah. Doesn't matter which 2 for the first expression, just you're going to take 2 of them. All right. What is the most number of common y's? 1. All right, so my greatest common factor, GCF, is going to be x squared y. All right. Now, what we want to be able to do is get that from the original expression or expressions. I don't want to have to write it out because if it's x to the 30th, y to the 70th, that's going to take all day. All right. So what we're going to do is we're going to look across our different expressions and we're going to just take note of the different variables that populate the expressions. And we're just going to take the power that's the smallest. All right. So if I have x cubed, x squared, and then another term that has x to the first power, then I'm just going to pull out an x to the first. All right. So I'm just running across and taking the variable that's raised to the lowest power out of all of the different options. All right. That's the nifty little shortcut to this. All right. So it's kind of weird because we tend to think of greatest common factor, or greatest as being the largest, and then, you get into least common denominator, you actually go the other way and choose a higher exponent. So it's kind of a reverse sort of thing. Mm-hmm. So we're going to be able to factor expressions, and I'll show you how you can check it on the calculator in a minute. So we know about the distributive property, at least in its most basic sense. Distributive property is just telling us to take a term that's on the outside, or a coefficient, and run it through whatever the expression is on the inside. The important piece being that that expression inside the parentheses has to have a plus or minus, right? It has to be a binomial or better, all right? So it's going to be a polynomial, all right, in order for the distributive property to take place. All right, what we're going to be given now are problems that have already been distributed. We have to undistribute them, all right? So we have to figure out what the expression was in front of the parentheses before it was distributed through. In order to do that, we got to find the GCF. So let's take a look at number one. So I got two terms here. I got 20 x squared, and I got negative 15x. All right. So maybe you don't really have a good handle on the numerical values. So you go to your calculator, you do math, go to NUM, GCD. Just type in the positive variations of the number. You could put in negatives too, but it's not necessary because you can handle the negatives yourself.
Why is it called GCD instead of GCF?
Because they use divisor instead of factor. Divisor means the same thing as factor, so it's just whoever programmed the calculator decided that that's the way they wanted to do it, even though they're the only ones who say that. They're jerks. I hate them. Yeah, it makes my life more difficult. So yeah, so we got the 5 there. Now, looking at my exponents, I have x to the second, x to the first, right? So I'm going to choose the one that has the lower power. So put it all together, I'm looking at a GCF of 5x. All right, so that's what's going in front of the parentheses. Then what I'm going to do is divide each one of these original terms by that GCF. I'm going to divide by the GCF. All right, so what's 20x squared divided by 5x? 4x. What's negative 15x divided by 5x? Negative 3. All right. So you could check by distributing, but I'm going to show you a different way. I'll show you a couple ways, actually. Yeah. Actually, I'll show you one way. I'll try to keep it simple today. All right, so to check your answer to make sure it makes sense, go to y equals. We won't use the test menu. Type in your original expression as a function. So instead of just writing, like in your home screen, 20x squared minus 15x, we're going to write it as y equals. We're going to write it as a function. 20x squared minus 15x. And then type in your factored expression. All right, you don't have to look at the graph. All you need to do is go to the table of values. So second graph, and make sure your y's are the same. Your x's should always give the same y's if your expressions are equivalent. All right. So now I know that they're equivalent. The only drawback to this is it's telling me that my answer is equivalent to the question, but what if instead of taking out the greatest common factor, just going back to the do now problem, what if the numbers were 72 and 96 and I thought the GCF was 12? I'll get something that's equivalent to the correct answer, but it won't be the simplest form. All right, so there's still a part where you have to do the thinking, but you can definitely streamline it a little bit. All right, so let's hop down to something a little juicier, like number 9. So here we have 3 terms. So we're doing the same thing. We have our 3 terms, 1, 2, and 3. I wanted to show you how the GCD function works on the calculator for 3 terms. All right, you just do them 2 at a time. So you would do GCD on 10 and 2. All right, so math, NUM, option 9, or GCD, whatever it is in your calculator. 10 and 2 gives you a 2. And then work that 2 against the 14. I recommend you do this a bunch of times, even for cases that you know early on in the process, just so you can kind of I'll call it developing muscle memory, because what happens is people have every intention of learning this technique, and then you don't need it for a lot of problems, but then when you do need it, the next time you really do need it is the day of a test, and you can't remember how to do it, and I can't tell you. All right, so practice using this technique a little bit early on. Maybe write it on the front cover of your packet. Math, NUM, option 9. I think it's option 9. Just double check in your calculator, make sure it's it is okay, and just say that that's to find a GCF between 2 numbers. Just so you see it every time you open your packet. All right. So we know that. Now to get the full-blown GCF, we know it's going to involve a 2 from that. Now I'm just going to look across my exponents. I have h's everywhere. If a variable isn't present in each term, we disregard it. All right? So we have h's in each term. What is the lowest power of h? H to the first. So I'm just going to write an h. All right? So I'll just tuck the 1 in there. But this is the one that we want. All right. What about the ends? Yeah, same deal, right? Also n to the first. So that's our GCF. So that's the expression that's going in front of the parentheses. We're going to divide each term by that number. All right? So we need 10h cubed n cubed divided by 2hn, which is going to be 5 yep 5h squared n squared, yep, minus just an n, yep, plus 7. All right, so very procedural. And again, that GCD stuff, like I said, it's not 100% required, but you can definitely see the benefit of it. For me, sometimes I want to just take a break from thinking. And it's as simple as that. I just don't want to have to think about it. I see a 17 and a 51. Does 17 go into 50? It does, but I don't want to have to think about it, so I just type it in. So that's kind of where I am with that. Maybe that's where you would be too. I don't know. All right, so. Well, now you know I was full of it when I said I was done with the lesson, because it did take me 20 minutes. All right, so I'm going to look at my 2 terms, and I'm going to find the greatest common factor between those 2 terms. I have a 44a squared, and I have an 11a. I'm going to focus on the numbers first. So in my calculator, I'm going to type, or I'm going to select the GCD. Now you can do it in your head if you want, but I recommend familiarizing yourself with the calculator function because the day of the test, you don't know what numbers you're going to be presented with. All right. 44 and 11. Now, if there's a negative number, you know, you see in number 3, there's a negative value, you're going to disregard the negative. You're only putting positive values into the GCD function. Otherwise, you get an error. All right. What does the calculator tell you? 11. All right. So now I'm going to look at my A terms. All right. So I have an A squared and I have an A. So what is the most amount of A that I have across the board? One of those A's, right? All right. If you were to expand it out, you'd have an A and an A for the first one, and then just a single A. So as a little bit of a shortcut, what you could say is, all right, I'm really just choosing the A that has the smallest power to be part of my GCF. All right. And that's where people get jammed up on this because you say, wait, I'm taking the A that has the smallest power, but it's the greatest common factor. Yeah, that's what makes it quirky. All right, so my GCF is going to be 11A. All right. So that's going to go in front of an open set of parentheses. Because factoring, I mean, it wouldn't sound as interesting this way, but factoring is also known as undistributing. Right? So basically you're doing the distributive property in reverse. Right? So what we should have here as a result is what you would have gotten as a question in the last unit. Right? So I have an 11A out front. I want to be thinking about what I would have to multiply 11A by in order to get 44A squared. And then also 11A multiplied by something to give me an 11A. The shorter way to think about that is to say, I'm going to divide each term in my original expression by 11A. Right? So what's 44A squared divided by 11A? 4A. What's 11A divided by 11A? 1. All right, I have a positive sign in the middle, so that's just coming along for the ride. So I just put a positive sign right in the middle. All right, we'll take a look at number 3. In your calculator or in your head, if you do it in a calculator, you're typing GCD 24 and 36. And what do we get? 12. All right, what about the variables? Well, in order to have a greatest common factor, there would have to be something in common to begin with, right? There is nothing for the variables, only for the numbers. All right, so I'm going to pop a 12 in front. And I want to be thinking about what I'd have to multiply 12 by to get 24y. 2y. And what I'd have to multiply 12 by to get 36x. 3x. All right. So in that case, you're not able to pull out a variable, but you are able to pull out a number. So you are able to simplify it a little bit, but not in a crazy fashion. Let's take a look at number 8, and then that's the last one I'll do with you, and then I'll set you loose. Right, so the calculator won't do it with more than 2 numbers, so what you have to do is work at two numbers at a time. All right, so we'll tackle the 6 and 9 first. What do we get? 3. And then take that result and put it in with an 18. And you get 3 anyway. All right, so we'll start with that. Now we're going to look at our variables. Is there an x in every single term? No. Is there a y in every single term? Yes. So what's the most amount of y that I could pull out? 3 of those y's. Right, so we take the y that's raised to the smallest power. That's going to be part of my GCF. So my GCF is going to have the numerical component 3 and the variable component y cubed. So 3y cubed goes in front. I'm going to have a trinomial here because I have 3 terms. So what do I get if I take 6x squared y cubed and divide it by 3y cubed? 2x squared. What do I get if I take 9xy to the 4th and divide it by 3y cubed? 3xy, yep. And finally, 18y to the 5th divided by 3y cubed. 6y to the 2nd. All of the signs in the middle are positive, so I'm just going to bring them along for the ride. And this is our simplest form. Your practice is pages 1 through 3. Classwork /homework. Yeah,